Good morning and welcome to today's T&D World webinar, Beyond Tradition, the Benefits of Composite Utility Poles for Long-Term Resiliency, sponsored by Resilient Structures. I'm Nikki Chandler, Editorial Director for T&D World with Endeavor Business Media. To begin, let me explain how you can participate in the presentation today. First, if you have any technical difficulties during the session, just submit that to the questions window, and our technical experts are here to help you out. We do recommend disabling any pop-up blocking software or extensions in your browser, as sometimes those can cause issues with that webinar player. Additionally, we do welcome your questions during the event. We'll answer as many questions as possible during the Q&A session that will follow the main presentation, but you can send in those questions at any time. To do so, simply type your question into that question window on the side of your screen and hit submit. To refer a colleague to today's discussion, share it on social media or access event resources, click the icons on the left side rail of your screen there. Also, please be aware that the session is being recorded and will be available on the T&D World website within the next 24 hours. You will be notified by email when that archive is available. Now I would like to introduce the speaker for today. We have Brian DiStefano, the Director for Sales Engineering at Resilient Structures. With 20 years of comprehensive experience in the utility industry, he's built a strong reputation as both a technical expert and a strategic leader. Brian has worked in several areas of utility engineering and operations, mainly distribution engineering and operations, and relay protection and control. In these roles, Brian was responsible for ensuring system resiliency and reliability, as well as managing complex engineering projects. Welcome, Brian. Now turning it over to you. Thanks.
Thank you, Nikki. Okay, well, thank you for that introduction. Good morning, everyone, and happy April Fool's Day. I promise not to play any jokes on anyone today. We're just going to get down to business. So my name is Brian DiStefano, as Nikki mentioned. I'm the Director of Sales Engineering and Technical Services here at Resilient Structures, RS for short. I lead our internal sales engineering team that consists of T&D line engineers and designers. I also oversee our technical services group, who provide on-site guidance and training to our customers that use our composite poles. I'm very excited to be here with you today and share my thoughts on the benefits of composite utility poles for long-term resiliency. Okay, so let's get started. First, I'll address the question, what are composite utility poles? I'll explain what they are, their key characteristics, and why they are an advantageous alternative to traditional materials like wood, steel, or concrete. From there, I'll provide a brief overview of our company, Resilient Structures, highlighting who we are, what we do, and what sets us apart. Next, I'll cover the handling, storage, and testing of composite poles. After that, I'll discuss various use cases, demonstrating how composite poles perform in different environments and conditions. I'll also share some real-world examples of their durability and reliability. And then to wrap things up, I'll touch on total cost of ownership, considering both initial investments and long-term savings that come with using composite poles. So what are composite utility poles? Well, before we discuss what composite utility poles are, I would like to share the definition of composite materials. Composite materials are defined as materials made by combining two or more substances with significantly different physical or chemical properties, resulting in a material with enhanced properties compared to its individual components. Okay, great. What does that mean, right? Well, when it comes to composite utility poles, sometimes they're called FRP poles, which stands for fiber reinforced polymer. They're basically made by combining fiberglass and resin, just like you see on the screen. We have fiberglass rovings, and they're soaked in resin, and they are made into a pole. Sounds simple, but it definitely is not. Exactly how these two materials are combined to make a superior utility structure, I will go ahead and explain that in some future slides. But just to get into a little bit of the individual components, the fiberglass that we use that's most commonly used is called e-glass or electrical glass. It's commonly used in many industries, including construction and marine applications. Of course, utility poles. It got its name because it originally was developed for insulating electrical wires, and then, of course, they found many other uses for it. So the fiberglass piece of it is very common. What really sets composite poles apart from each other is the resin that's used as well as the manufacturing processes. That's really what differentiates composite poles and composite utility pole manufacturers. All composite utility poles are a combination of fiberglass and resin, but not all composite utility poles are the same. Okay. So I'd like to just discuss the three primary resin types that are commonly used in the composite pole industry: polyurethane, vinyl ester, and polyester. Polyurethane resin is the resin of choice here at RS for a wide variety of reasons. We actually use a proprietary recipe of two different types of polyurethane resin that go into our product. I'll explain those two different types of polyurethane resin later. But just to get into the individual resin types, polyurethane is very strong and it's very impact resistant. It's got excellent UV resistance, excellent screw retention, offers very, very good balance of flexibility and durability. Downside is it's definitely the most expensive among the three. It's also very difficult to use in a pultrusion manufacturing method, which I will get into that as well. The happy medium is kind of the vinyl ester world, where it's less expensive than polyurethane. It's easier to manufacture with and to handle. It provides good durability, provides excellent chemical resistance, bonds very well to various substrates. Like I said, it's less expensive than polyurethane, but it is more expensive than polyester. This particular resin, along with polyester, uses styrene to help the resin cure. Styrene is a chemical that it's got a very distinct smell. If any of you have ever walked into like a boat yard where they're doing hull repair, where they've got fiberglass matting soaked in resin, it's very distinct, very strong smell of volatile organic chemicals, VOCs, that are emanating in the air. You cannot mistake it. So for the comfortability of manufacturer workers and just for residents or other businesses in and around a manufacturing plant that uses styrene, it's not the most comfortable type of environment. Polyurethane, on the other hand, does not use any styrene. So when you walk into one of our manufacturing facilities, you can't smell anything. It's much more comfortable. Then we get into the polyester resin, which is the most cost effective. It's the cheapest out of the three. It's very easy to use in manufacturing. It bonds very well to various substrates. It's got less chemical resistivity. It's got less water resistivity. And one of the big problems with it is it can shrink during the curing process, which causes internal stress on the finished product. So it's not really ideal. Okay. Next slide. So here, what I wanted to do is just briefly share some of the mechanical properties of the three different resin types. After reviewing this slide, it should be pretty evident why RS chooses to use polyurethane resin for its poles. When you compare the three resins, you compare their flexural strength, their compressive strength, bearing stress, and interlaminar shear. What you'll see is that polyurethane outperforms vinyl ester and polyester by a significant margin. These reasons, coupled with polyurethane's outstanding UV resistance, is why RS chooses to use it despite the fact it's most expensive and difficult to manufacture with. Manufacturing with polyurethane has taken RS years of R&D to perfect, but we believe it produces an absolutely superior product. Okay. Now, allow me to shift and discuss two different composite pole manufacturing processes. Okay, filament winding. This is the process that RS currently uses to manufacture pole modules that make up our composite utility structures. The process involves saturating fiberglass strands with resin and then tightly wrapping them around a tapered mandrel. You could see it in the illustration on the slide. Multiple alternating layers are applied to the mandrel with fibers arranged both around the circumference of the mandrel as well as along its axis. The circumferential layers enhance the hoop strength of the structure, while the axial layers contribute to its bending strength and overall stiffness of the finished pole. So after constructing the module, the resin bath is switched out from an aromatic polyurethane resin to an aliphatic polyurethane resin. This is the first time I've introduced those terms, and I'll explain a little bit more about that. The aliphatic polyurethane resin, which is the outer coating of the module, is tinted to give the pole its final color, either brown or gray. These final circumferential layers are applied with a very high resin content, higher than the resin content of the structure beneath. That results in a very resin-rich surface that boosts the finished product's durability and significantly enhances its UV resistance of the entire structure. Okay, and then once that happens, the mandrel is then sent into an oven for the resin to cure, and then the product is complete. So here is a cross-sectional image of one of our poles. You can observe the distinct layers. The gray regions consist of the aromatic polyurethane. That that aromatic polyurethane, although it doesn't have great UV resistance, it gives the pole its excellent structural integrity and provides the core strength and structure of the pole. And then the outer brown layer gives the pole its final color. But more importantly, that is the aliphatic polyurethane layer. That offers durability and UV resistance, as I mentioned in the prior slide. UV exposure is the primary cause of composite degradation. All composite poles include some form of UV protection. They must. So a lot of manufacturers will actually apply a thin UV resistant paint that's microns thick. Our product features an integral outer layer being 1 to 2 millimeters thick of aliphatic resin, ensuring that the pole doesn't chip or require any kind of periodic reapplication. The robust design here is crucial for the long-term resiliency, particularly in extreme environments. It enables the utility to rely on the performance of the product engineered to endure over 80 years with no required maintenance. So we're pretty proud of that process. Moving on to this slide. So you can see here in the image, there's a completed pole module freshly removed from the curing oven. This particular pole module is gray to resemble steel. We also, like I mentioned, we also produce brown, which mimics wood. Common question we get from utilities is why we don't use a veil cloth. Reason for that is in pultrusion processes, a veil cloth is typically required to achieve a resin-rich surface, which prevents fiber blooming, and it also gives the pole its strength, its outer layer of strength for damage. So our manufacturing method inherently produces a resin-rich surface without having a veil cloth necessary. So we don't need to add a veil cloth. Final resin-rich surface with all that aliphatic resin provides the finished surface. That's actually a pretty common question that we get. So I mentioned pultrusion a few times. Just to go into the process a little bit more, pultrusion is a manufacturing process in which the resin-saturated fibers are pulled through a heated die. Okay, very different than filament wound products. This forms a resin-rich surface I'm sorry, to form a resin-rich surface in pultruded poles, a veil cloth is typically required, which is what I mentioned in the last slide. One advantage of this particular method, though, is its continuous operation. Parts can be manufactured indefinitely and then cut to the desired length, all without interrupting any production. Pultrusion also produces a uniform, non-tapered profile. However, the height of the pole made through this process is limited by its base diameter. So larger dies would be needed for wider bases, which could require having to change out equipment, causing production downtime. Also, using polyurethane resin in this manufacturing process presents many challenges and is quite difficult. Okay, so now I'd like to move on and talk a little bit more about resilient structures and what makes us unique. So Resilient Structures, RS, was founded in 1995 and have been making composite utility poles since 2005. This year, we're proud to celebrate our 30th anniversary in business and our 20th year making poles. We have invested over $400 million in composite material science, R&D, and commercialization. We currently hold 71 patents and 13 trademarks. We have had no structural failures due to extreme weather events. We manufacture 11 modules that can make up over 260 different pole combinations, finished pole combinations. An overwhelming majority of what we sell and deliver, however, are fully assembled poles, similar to the way that you might receive a wood pole. Customers generally like that because if they're not space constrained in their yards, it's much easier just to pick up the pole and set it just like you would a wood pole, rather than having to put it together on site. We have over 500 customers in 30 countries around the globe. And since 2005, we have manufactured 1,200 linear miles of poles, which is enough to stretch from El Paso, Texas, on the west side of Texas, all the way to Montgomery, Alabama. Okay, so we've strategically located our 3 manufacturing plants in Ontario, Utah, and Texas to serve customers throughout North America. We have a production capacity of over 50,000 poles per year. We are well insulated from global supply chain disruptions, which was proven back in COVID days. And we are positioned to scale our operations as our customers' needs grow. We find to be very important, and is why we've placed these manufacturing plants where we have. Okay. So this slide, this is a graphic I wanted to include that helps better explain our product line and how it works. So I did mention that we have 11 modules, and that is true. But this particular graphic is missing 3 of them. We have a couple of long modules, and then we have an M56. But it gets the point across pretty well, where it shows a bunch of different modules and just a myriad of pole options, anywhere from light duty street light poles all the way up to transmission level structures, H-frame structures, monopoles, generally up to 345 kV, 150 feet, and anything in between. We also sell poles for communication applications as well. So I thought this was helpful just to kind of just to explain how we operate and how our modular system operates, and just the versatility and flexibility we have by manufacturing these modules. Okay, so I'm going to move on to handling, storage, and testing. All right, so in this slide, displayed on the left side of the slide, is a graphic that highlights the shipping advantages of composite poles, specifically the nested composite poles, right? So because we make modules, and those modules stack on top of each other to create a pole, we could also stack them in reverse to nest within each other, right? So that's a really big benefit. As you can see on the left side, you may or may not be able to see that. It's kind of hard to read, but you could get 53 60-foot monopoles on an average truck, when that's compared to 27 steel, 15 wood, and 6 concrete. So major shipping advantages there. Um, and not only are the composite poles the lightest option available, but as I mentioned, with the modular design, you could really pack them in, which is nice. Now on the right side, you'll see a graphic comparing composite poles with wood, steel, and concrete in terms of strength and weight. The graph in the middle, it says specific strength comparison. We evaluated specific strength or strength per pound, and composite poles outperform the alternative significantly, right? And as you can see here, the chart is a little misleading. It says strength, but it's specific strength, right? Pound for pound, composites definitely outperform the alternatives. Now, the weight comparison also, this is just a straight weight comparison. It highlights how much lighter composite poles are compared to other materials, which makes shipping, handling, and installation that much easier. Okay. So the photos shown here are there's workers. One's drilling our pole, and then another worker's there. You see him. He's removing the shipping bolt from a nested set. Um, Drilling composite poles. We get a lot of questions about drilling composite poles. It's remarkably easy as long as you have the right drill bits and a typical battery operated drill. It works just fine. It's easier. It's even easier than drilling wood poles, and it's definitely easier than drilling steel or ductile iron. Um, Additionally, we also get a lot of questions about the dust created. Right, the dust generated from drilling or cutting is inert. It's non-toxic. It's simply a nuisance dust, and all we recommend is a basic dust mask for PPE while drilling or cutting. Okay. Um, On this slide, you'll see two more photos. The two photos depict workers moving the pole modules. On the left, they're moving it by crane. This could also be done by a digger derrick, typical distribution truck. Um, they're moving this by crane because they're moving the entire nested set all together. Um, excuse me. When the modules are unnested, you can see the picture on the right. Each module can be easily lifted by a sling and 4 workers. This manual handling capability is really advantageous in locations where heavy equipment access is limited or even prohibited. We often get questions about storage. Storing composite poles is very straightforward. It's easy. It's just like storing any other pole. You can store it outside. You can store it indoors. You could store it fully assembled, like the picture on the left. You could store them fully nested, like the picture on the right. Um, some customers opt for nested storage because of obvious space savings, and they're tight on space. This is also a really great option if you're trying to gear up for a storm and you needed some poles delivered in the field at different locations, temporary locations. This is a really good space saver. Or like I said, you could have them fully assembled at our factory. We would ship them to you as a full piece, ready to install. Testing. Okay, so I could pretty much take this entire presentation to talk about the testing that we've done. I've added one slide here to just give you a little taste of the testing that we've done over the years. RS has invested very heavily in both in-house and third-party testing, covering everything from strength of the product, hardware failure, freeze thaw cycles, electrical insulation and tracking, UV exposure. We've done extensive UV exposure testing, and of course, fire resistance. So not to spend too much time going into each one of these tests, I have lots and lots of data and reports and information about all the testing that we've done. I am very happy to share any of that with you after the presentation. So if that's something of interest, you could reach out. My contact information will be on the last slide, and I also believe it's somewhere on the screen here now as well. If not, it'll definitely be on the last slide. Okay. So when are composite poles the right choice for utilities? Well, we would love for every utility to adopt composite poles in all scenarios all the time, right? But that's neither practical nor necessary. However, incorporating composite poles strategically can play a very key role in enhancing long-term resiliency for your system, a quality that is more critical today than ever before, right? So for the past 20 years and working with our utility partners, we've learned that there are three primary use cases for resiliency via the use of composite poles. One is critical circuits and structures. Second is structures with high initial installation costs. And third being areas where conventional structures do not last. We get into each one of these in detail. Okay. For critical structures and circuits, there are several applications that this can apply to, right? The first one being the cost of replacement equipment. Keeping expensive equipment that also contributes to system reliability. Keeping that in the air on a pole that doesn't break is critical. These pictures depict a recloser on the left, a set of voltage regulators on the right. These are both expensive. They're both critical to reliability of the distribution system. This is an example of equipment that you do not want to have to replace, especially in a storm scenario. The list goes on. These are just two examples. Transformer banks, cat banks, manual switches, motor operated switches, smart grid equipment, you know, and the cost of all this equipment varies widely, but it could get very expensive. These are things that you choose not to have to replace, of course. Uptime criticality. The photo depicts a complete distribution line rebuild using RS poles. This was designed to eliminate the need for pole replacements during adverse weather events. Prior to this particular upgrade, the utility incurred significant damages after a business that was fed off this line suffered revenue losses due to a power outage. We've also assisted customers in designing skip bolt strategies, where our composite poles are installed every third or every fifth pole along traditional wood pole lines. This approach helps prevent cascading failures of wood poles because the composite poles keep the line up, and it basically arrests the cascading failure. And it offers a really great cost-effective solution for customers who want to harden their system or harden specific circuits, but may not be ready for a full upfront investment of replacing all wood poles with composites. So that's a really good alternative. Excuse me. Okay. Complexity of rebuild. Poles with underground risers are a great candidate for this particular long-term resiliency solution. These poles on the screen, if they fail, they will significantly affect the reliability of distribution system, and they could take a long time to rebuild. These are riser poles that come right out of a substation. These are like direct circuit riser poles that feed out into the field overhead. If one of these poles fails, you're going to lose the substation breaker. It's going to trip. That circuit's gonna become de-energized. And based on what you have on that circuit, if you have any smart equipment that could automatically switch around the fault, that'll happen. If not, you have to manually switch it. But nevertheless, you're putting your system at risk, because even if you do pick up the customers using switch maneuvers, you still will be down one circuit until all of this gets replaced and repaired, and that could take some time. So employing an RS or a composite pole, as what is the case in this picture here, pretty much ensures you that you're never going to have a problem here. Not unless a backhoe or a big truck or something runs into these guys. Okay, environmental impact. So the photo here depicts a three-phase transformer bank on the ground following a recent storm in Texas. While the loss of this pole impacts the commercial business that it's serving, um, the more pressing issue is the fact that two of the transformer lids have come off, resulting in all the oil inside those transformers leaking into the adjacent storm drain. Significant environmental impact to the community and liability for the utility. This is a pole, if it were me and I was back in the utility, I would definitely never want this pole to come down. Okay. Moving on to the second use case. So all the slides I just talked about for the past 5 minutes, that's all part of use case number one, which is critical circuits and structures. Now we're getting into structures with high initial installation costs. So structures with high initial installation costs are areas where heavy equipment is not an option or will damage property. In these areas, heavy equipment cannot be used. Being able to install a utility pole using only manpower and hand tools is a major advantage. Now, unfortunately, this does not include all composite poles. This includes specific composite poles like the ones that RS sells. We sell modular poles, which can be built from the ground up, stacking the modules one on top of the other, which are with our gin pole tool, which is that orange pole in the picture. Since these poles are engineered for long-term resiliency, utilities can be confident that replacing these poles, going through this exercise of hand building this pole in an area that's hard to access, you will not need to return to this location for the next 80 plus years, right? Unless something significant happens. But in general, there's not going to be any maintenance required on this pole, and it's a resilient structure, and it'll stand the test of time. Okay. Moving on to remote areas and or challenging terrain. Composite poles are significantly easier to transport, as we talked in some previous slides. And due to their lightweight design, it makes them an ideal choice for hard to access areas. They're maintenance free, as I mentioned, long lasting, reduces the need for replacements, but also eliminates maintenance costs associated with the structure. That's a really good benefit and advantage when you have poles in areas that are very difficult to access. Installations in and around wetlands. Composite poles are ideal for wetland installations. These structures are completely inert. As I mentioned earlier, they do not leach chemicals into the ground at all. Polyurethane-based composite poles, like the ones at RS, those poles excel at keeping moisture out of its internal laminate structure, thereby not only from an environmental impact, no leaching chemicals into the ground, but it also enhances the overall resiliency and extending their lifespan where other structures would not do as well. Okay. So then we have, moving on to the third use case here, which locations where conventional structures don't last. Wildfire-prone regions, we've recently seen an uptick in this use case, as you may imagine. Composite poles are designed to be non-combustible. Specifically for ours poles, we talked earlier about the outer aliphatic resin layer. This functions as a sacrificial barrier, helping maintain structural integrity of the inner aromatic layers during wildfire events. Furthermore, their inherent electrical insulation properties and hydrophobic surface prevent the initiation of fires due to electrical tracking. We've done extensive testing in this area, and like I said earlier, if anybody on the call here would like any of that information, please feel free to reach out. Okay, destructive wildlife, woodpeckers, beavers, bears, termites, right? Also areas with poor soil chemistry where wood poles just don't last the way they're expected to. Many of you may be familiar with areas where the woodpeckers frequently damage poles. I know in my area here, when I was in the utility, we had this problem. We also had a problem with beavers. They chew through them, leaving behind a weakened pencil thin base. The poles just waiting to fall over. Composite poles are engineered for long-term resiliency, and they do not attract destructive wildlife at all. That includes woodpeckers, beavers, bears, termites. They remain unaffected by any of these challenges, including soil that's not ideal, right? Doesn't affect composite structures at all. Um, Areas of high salt environments, like the one pictured, or like coastal areas. The H-frame structure pictured shows it installed directly into the salt bed of Utah's salt flats. This is an RS structure. It's an H-frame structure that we installed a little while back. This demonstrates its remarkable resilience, something most other materials would really struggle to achieve in this type of corrosive setting. And that's actually not snow on the ground, that is salt. Um, Composite poles, along with stainless steel hardware, resist the damaging effect of salt exposure, making them especially suitable for both inland salt flats like the one pictured, or coastal applications where corrosion is a constant challenge. We've performed several jobs for customers all around the country along coastal areas for this exact reason. This solution is tailored to deliver robust, long-lasting performance in conditions that would rapidly degrade less specialized structures. Okay, then we have ice-prone regions. Because composite poles are able to absorb heavier loads without breaking compared to their wooden counterparts, they are a great option for long-term resiliency in ice-prone regions when the buildup of ice on wires and equipment makes the overall system that much more heavy. Okay, moving on to some case studies. We have a slide here showing some recent cases where RS composite poles were used specifically for long-term resiliency in areas threatened by extreme weather events. And I hope that these pictures are legible. I will walk you through them. There's some points I want to make here. Starting on the top left, this is the August complex fire in 2020. This occurred in California to one of our California customers. It was classified as a rare gigafire. Over 1 million acres affected, with millions without power. Although our poles were charred, they held up very well in this and in many wildfire events. This has become a significant use case for us. The next photo down, the derecho storm in 2024 in Texas. This was 100+ mile-an-hour winds, tens of thousands without power. What I want to focus your attention on here, and I hope it comes through, in this photo, there are two brown composite poles, and they look like they're bent a little bit. Between those two poles is a distribution conductor. On top of that distribution conductor are 3 phases of transmission line that have come down due to a failed lattice tower in the background. The distribution line, along with the composite poles, is holding those wires up. No composite poles had failed in the derecho storm in Texas in 2024. So we're very proud of that. Back in 2016, Hurricane Matthew in Grand Bahama, Category 4 storm, 150-mile-an-hour winds. Thousands of wood poles were lost, as they normally are in those types of events. In this picture on the top right, you can see in the foreground close to the street, we've got a failed wood pole. On the field side of that wood pole is another distribution line. That distribution line is all composite, still standing. The picture in the right middle, Kentucky tornadoes, 2021, EF scale 4 intensity, 160-mile-an-hour winds. There were many wood pole cascading failures. You could see here we've got a pole that's broken about 8 feet above ground line. Right next to that pole on the right-hand side, we got 2 composite poles still standing. And then this last photo is a screenshot of a text exchange between one of our sales managers back in 2019 with one of the operations managers down in Grand Bahama. They had gone through Hurricane Dorian, Category 5, 200-mile-an-hour winds, thousands of wood poles lost, right? And we always like to show this, something that we're very proud of. The text exchange, and I don't know if you could read it, but basically it's the sales manager reaching out saying, hey, I hope you guys are good. I hope you're safe. And he sent back a text that said, we are safe. Looks like your poles survived again. So we always like to share that. Okay. Finally, I'm going to close the presentation with a slide on total cost of ownership, some factors to consider. What is the cost of long-term resiliency, right? Well, that's a good question. So if you look at some of the bullet points here, what is the value of a near zero failure? It's really an insurance policy. And as I went back through some of the use cases, this is a no-brainer when it comes to critical circuits and structures. We're not saying that you have to just replace every single pole on your system, but if you strategically deploy these structures of areas of critical structures as well as critical circuits, you're going to see a major impact to the overall resiliency and reliability of your system, and you're also going to save money. The expected pole lifespan and replacement interval. This is something that wood pole owners have to deal with, right? Generally speaking, wood poles last about 40 years, right? That's what I've always heard. I also spent some time in Osmos, and I know that's usually the time frame that is communicated. For ours, we have done extensive UV testing and moisture absorption testing, and we found that under the harshest UV environments, we are able to last at least 80 years. This is generally a lifetime product, right? The pole lifespan, it's 80 plus years. There really is no replacement interval. And then to move down to the third bullet, O&M costs, maintenance, restoration, and replacement programs, they go away. You don't need to maintain, restore, or replace. That being said, if a car hits a pole and it breaks, of course you have to replace it. But in general, due to the lifespan, the expected lifespan of the structure, the O&M costs go away. Costs of unplanned or planned replacements during storms. During storms, it's a very stressful situation. You've got lots of people out of power. Labor is at a premium. Materials could be at a premium. That's if you can find them, right? So that's a huge benefit. Value of electrical equipment on the pole. We talked about that earlier, reclosers and regulators and smart grid equipment and anything that might be mounted on that pole. Also, the availability of that equipment and those poles. We recently saw back in 2020, 2021, 2022, wood poles are really, really difficult to get because of the supply chain issues. A lot of folks don't realize this, or don't consider this, I should say. Lost revenue due to unexpected pole failures. When you have a storm or you have a significant outage where you have to replace poles, that outage is going to last a long time, a lot longer than if you didn't have to replace those poles. During that time, the meter stopped turning. That's lost revenue. And then, of course, finally, you do have to consider inflation and cost of money. Money today is going to cost most likely less than money 10, 20, 40, 80 years from now. Okay, and with that, we have come to the Q&A section of the presentation.
Thanks so much, Brian. That was a great presentation. And to tell you the truth, I wouldn't mind seeing some of those manufactured at some point. So maybe we can get out there. So a few of you have already submitted questions, and so we're going to jump right into those. As a reminder, if you would like to submit a question, just type that question into the window on the side of your screen and hit that submit button. Also, please stay until the end of the presentation to complete that exit survey. That's going to pop up on your screen. You can preview those questions now by clicking the exit survey icon on the left side rail. Okay, let's go ahead and jump into your questions. Like I said, we have a few here. And some of these were addressed a little bit in your presentation, Brian, but I think it'd be great to revisit some of those questions and get a little bit more clarification. So first of all, what advancements or innovations are being made in the composite pole industry? You did a great job of explaining, where it's at to this point, but are there any advancements or innovations being made, and how do they improve safety and reliability for those utilities?
Yes, I appreciate the question.
Mm-hmm.
I actually just got knocked off of the presentation, and I had to
Okay.
I had to sign back in. So now everybody gets to see behind the curtains of my wonderful backdrop. So I just have to fix that if I can.
No problem. I really, I was just,
I got it.
yeah.
I got it.
Okay, cool.
Yeah. Sorry.
I was just going, yeah, that's okay. I was just going, Looks good.
Okay, so now I'm ready. Now I'm no longer distracted. Okay, good. So yeah, if you wouldn't mind, Nikki, can you just repeat that question, just so I make sure I heard you correctly?
Sure, sure. And like I said, I was just, when you kind of dropped off, I was letting the audience know to submit questions, even now. But what advancements or innovations are being made in the composite pole industry? Like I said, I know you went through, the technology up until now, but are there any advancements or innovations being made? And how do they improve the safety and reliability for utilities?
Sure, sure. So yeah, so there have been some pretty remarkable innovations being made in the industry. Um, on the material side, improving materials like the fiberglass and resin I talked about earlier for even better performance, longer lifespans, and actually, there's been a lot of research recently in wildfire applications when it comes to resin and the materials that go into that. There's also been some advancements on the manufacturing side of the house regarding process improvements. Cost is always something that needs to be considered when you're in business and you have competition, right? So cost competitiveness, lowering manufacturing costs through technology advancements or economies of scale. One thing that I really find interesting is there's some smart integrated technology going on right now where there are folks actually adding sensors and monitoring equipment to some of these composite structures that can sense things like temperature, wind speed, structural integrity, to gain data of how distribution and transmission systems actually operate in the wild, so to speak. All that data is going to really be able to push innovation forward even more. So I hope I answered that question well.
Yeah, for sure. And we were at Distributech last week, and we that was really kind of the story. There was a lot of that integration of technology, a lot of partnerships being announced, and so that was really kind of what we got out of where the industry is going. This is a really good one. Can composite poles be recycled or repurposed at the end of their life cycle? And I think we had a couple questions come in on that.
Yeah, that's a great question. We get
Mhm.
that question a lot. So recycling composite poles is quite challenging currently. That doesn't mean it cannot be done. What we generally tell our customers is that this is a landfill item for now. However, that being said, um, you know, just to go through some of the difficulties of recycling, separating the fiber from the resin is not easy. Um, there's also infrastructure limitations on recycling companies to do that. However, there are two methods that I'm aware of that haven't really become super mainstream just yet. But there's mechanical recycling where composite poles can basically be ground into like small particles, and then that gets added to things like concrete for reinforcement or asphalt for paving or other construction materials. But there's also another process that I'm familiar with that's really interesting. It's thermal recycling, pyro, 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 how do you say it? It's like pyrolysis, I think it's called pyrolysis. Basically what happens there is you take the material, you put it in an oxygen deficient environment, and you burn away the resin, and all you're left with is the fibers. And then you take those fibers and you use that, and you add that into other materials. It's a cleaner way to add materials because you don't have all that resin mixed in. Those are two areas that I'm familiar with recycling options. But I don't think, like I said, it's not very mainstream at this time. So we generally just tell folks to throw it in the landfill.
Okay, so that makes sense for now, but it does sound like there are some things being worked on as we kind of uh, move forward into the future. Where are you all located?
Oh, okay. So as I mentioned, we have three manufacturing plants. We have one in Ontario, Canada. We have one in St. George, Utah. We have one in Houston. Me personally, we have employees located all over the place. Generally speaking, the sales team is kind of spread around remote. I am also remote, but those are our main locations: Ontario, Canada, St. George, Utah, and Houston, Texas.
Okay. So I know you talked about a few use cases, and this is maybe a little bit of what this question is, but does the salt used on road even, can that affect resin integrity? Like, for example, poles near the road, obviously.
Yeah, yeah. So we get that question a lot too. Salt spray from salt being used as ice
Mhm.
melt on roads. It's a very very similar chemical composition as sea spray coming off an ocean. Or I showed a photo of an H-frame structure being installed directly in the salt flats in Utah. It's basically the same. We have significant tests around chemical resistivity of our product. I've got a whole list of all kinds of chemicals that our product is resistant to. I'm happy to share that if anybody wants to see that. Yeah.
Okay. And this is another one of the use cases that you had mentioned too, and maybe even went into a little bit, but the resilience to fire. And I know you'd mentioned that even in an innovation. Could you talk a little bit more about how these poles might be better for that wildfire mitigation?
Yeah, sure. Wildfires are tricky, right? We've done extensive testing in-house and also paired with Mark Ackerman in Canada to really put our product through its paces. And what we found is we've done a 2-minute burn test, a 3-minute burn test, and really what it comes down to is heat flux, which is basically the product of the temperature of the fire as well as how long the product is exposed to that fire. And generally speaking, if you have a 4-minute fire with very high temperatures, at some point everything's going to burn, right?
Mhm.
But in general, what we see is we see fires starting ground level brush to about 20 feet up the pole. We'll find our pole, the aliphatic outer layer will burn away. You'll start to see some of those fibers come through. Uh, I told you earlier that I oversee the technical services department. Part of our service for our customers, if you do have a wildfire come through, we will send one of our technical services folks out to your location. We'll do a proper assessment of that pole to see if it needs to be replaced or it can be rehabbed. But really, what we try to get customers to understand is you are going to have a product that is not going to support combustion like a wooden pole will. So if a wooden pole is exposed to fire, it will continue to support combustion. It will continue to burn until there's nothing left of it. That is not the case with composite structures, right? With our poles, they'll, like the resin, the outer layers of resin will burn. It could go further into the structural integrity of the pole. But generally speaking, what we found charred poles that are still standing. And for our customers, that's a huge win, because then the customer, when the fire has been extinguished and they have a chance to get out there, they can make a determination: should I replace it? Should I repair it? But at least my power is still on, and the wires are up where they should be.
Yeah, for sure. And we're seeing regions now that weren't affected by wildfires that are now. So more utilities are probably having to consider those areas. So here's the next question. What about climbing these poles? Does it have access for through bolts for steps or foot legs or foot pegs? Yeah, foot pegs.
Yeah, so climbing composite poles is pretty much identical to climbing steel structures. It's done by steps. We've actually partnered with several step manufacturers. We've done extensive testing as well. We have a step that we generally recommend made by VAF. It's a United States company, and they make a phenomenal product. Basically, you drill a hole in the side of the pole, or we could pre-drill it at the factory if you want it. If you want the poles to come with step holes, we could pre-drill all that, and then you just hook the step in, you tighten it down with the nut on the outside. Comes with a fall arrest loop, and it's just like climbing a steel pole.
Okay, cool. Thanks. Here's another one. We have about 5 minutes left, so we've got a few more questions here. Are there any special logistical considerations for handling composite poles, or are those managed similarly to wooden poles?
Yeah, so it's very similar to a wooden pole. The big advantage to our composite poles is, they're much lighter than any other alternative, so it makes it easier. One thing that we always are very cautious about when our technical services team go to the field and do training and guide our customers on how to use our poles. If customers are customers that like to get them nested and then they like to assemble them themselves, there are other safety concerns that we go over. Pinch points. They're using chain hoists. There's all types of different work methods that are involved in putting the pole together. But other than that, as long as you sling the pole just like you would a wooden pole, and you use either a digger truck or a crane or anything that you might use to set a wood pole, it's pretty much identical. There are some nuances, but not much. And by the way,
Okay.
just to let everybody know, on our website, we do have a bunch of how-to videos on how to handle and install and work with the pole. Or you could reach out to me and I can provide that information as well.
Okay, great, thanks. So this is along the lines of, the climbing, but also, what are there provisions for attachments built into the pole, or are the attachments similar to wood? So that's an interesting question.
Yeah, so the hardware that's used on our poles is very similar to wood. Okay. The only thing that we recommend, well, we really require is you can't use cleated hardware, right? For obvious reasons. I mean, cleated hardware that's designed to like dig into the side of a wood pole, that would destroy the outer laminate structure of our pole. And so anything smooth, and curved, just like we recommend curved washers. We recommend any type of gain bases we could make use with our poles. We actually have bearing plates that'll go on our poles in case a particular piece of hardware doesn't fit just perfectly. In general, generally speaking, and the group that I oversee, the sales engineering group, we have a bunch of engineers that go through all of these requirements, all the hardware that customers want to use, and we can provide a solution for customers as the needs arise. But there's generally speaking, there are no special hardware that's necessary unless you wanted to use like stainless steel or a special type of galvanized product or aluminum, let's say. That's all. Otherwise, it's
Okay.
pretty. Yeah.
So are your poles, do they all have the conical shape, or do you manufacture straight poles?
Yeah, so our poles are tapered modules that stack together. Right now, that's what we offer. We offer a tapered module, and so when the poles are put together, the pole is just one tapered structure. We do not have non-tapered poles at this time.
Okay. This is an interesting question. What's your most common height or pole height that you sell?
That is a good question. It's interesting. So we started out designing and building transmission structures primarily. We still do that, of course, but back in, I believe it was 2014, 2015 timeframe, that shifted. So now about 80% of what we sell is targeted towards the distribution market and 20% towards transmission. I would say if I had to take a guess without looking back into any kind of revenue information that I have, I would say somewhere in the 45 to 55 foot range. Typical distribution level poles, generally class 2, class 1. That's what we see a lot of poles being sold as.
Okay.
Yeah.
I'm gonna go, yeah, we're just about out of time, so I'm gonna fit one more question in here before we close. Are there greater than 345 kV available?
That's a tough question to answer. We say 345. It has nothing to do with the voltage per se. When you get to that level, you get very high structures and you need lots of space between phases because the voltage is so high. And at that level, we really struggle to meet that application. 230 kV, we could probably hit all day long. But when it gets to 345, that's a case by case basis. So the answer is no, we can't go past 345, but we can do some 345.
Okay, makes
Yeah.
sense. Well, I am afraid that we've run out of time. We did have a few more questions, so for those that we didn't have time to answer, we'll be getting back to you via email. So that does conclude the presentation today. On behalf of T&D World, I'd like to thank Brian for his presentation and Resilient Structures for sponsoring the webinar, and of course, all of you for joining. Have a great rest of your day.
Have a great day.